Hi there folks, Gary Simmons here for the Game Institute with a getting started video for the Matchmaker Unity project. Now the reason I'm making this video is because at the time of recording we've finished the Matchmaker game, we've released the project to the community, but there isn't yet any training videos. Now I know that some of you are going to want to download the project and start investigating the source code straight away. Now although Matchmaker is really just a match 3 game, it's still a pretty complicated game with a pretty big code base, so it's not as simple as you might think. So this video is going to get you started on where to start your exploration of the project and really just what scripts you should be looking at and paying special attention to. Now I am going to assume at this point that you've already downloaded the installer of the game from Game Institute's website and you've installed it on your computer and you've read the release notes which describes how the game works and what all the various components of the game are, and you've also played the game a little bit so you understand what kitchens are, what ovens are and what ingredients are and how they play into the flow of the game. Now although Matchmaker is just a match 3 game, it's still a pretty complex project because firstly it uses asset bundles so that all of the game content is streamed in live by the runtime so that we can patch or update the game at any point without requiring our end users to reinstall the software. This means that we can add levels or we can add more bakes or recipes to the game without requiring you to download a new version of the exe. And this complicates the code base slightly, especially if you haven't done anything with asset bundles in Unity before. And of course it also has other components to the game. There's this whole resource management aspect where you can buy new ovens, you can upgrade your ovens, you can upgrade your kitchens, and you can practice new recipes so that you can bake cakes that have a higher monetary value. So do make sure that you play the game so you know exactly what you're looking at when you're looking through the project. So if we ever find ourselves thrown in the deep end with a Unity project like this, one of the first things that we're going to need to know is what is the first scene that is loaded and executed by Unity, because that's where our source code exploration is going to begin. Now if you've followed any of my other training courses here on the Game Institute website, you'll know that most of my Unity projects follow a pretty similar design pattern. They all have a scene called the Bootstrapper scene, and the Bootstrapper scene is responsible for creating some of those really important scripts such as the application manager and maybe the audio manager that are objects that are going to exist throughout the life of the application. The Bootstrapper scene generally doesn't really do anything by itself, but it just makes sure that the scripts that manage the whole game are instantiated and executing before any subsequent scenes are loaded. So we can see we have the Bootstrapper scene here, but even if I had decided to not call that the Bootstrapper scene, if I had called it something completely different, you can always find out what the first scene to explore is by going to the file menu and calling up the build settings, because the scene at the top of the build list is always going to be the first scene that Unity loads and executes, and thus is going to have the scripts that are first executed in our game. Now one of the things that I'm going to go into greater detail in a moment, but I'll just touch upon for now, is notice that there aren't actually many scenes in the build list. For example, if we look in our scenes folder in our project, we can see that we have Kitchen 1, Kitchen 2 and Kitchen 3. And these scenes are actually where the main gameplay takes place. This is where we mix ingredients to bake cakes. And of course if you've played the game, you'll know what the kitchens look like. There's 3 kitchens because currently we support 3 kitchen upgrades, and each kitchen upgrade is a new scene. So why aren't they in the build list? Well, that's because the kitchen scenes themselves, as well as pretty much all of the prefabs, things like baked goods, the ovens, the ingredients, they are all built into asset bundles that are loaded at runtime by the executable. So when we build the Matchmaker project, none of these kitchen scenes or none of the prefabs of the baked goods, the ingredients, the ovens, etc. are actually in the exe. We get a very small exe, and at runtime the exe will then stream the asset bundles with all of those assets in, including the kitchen scenes, from the Game Institute server. Now these are cached, so it means we don't have to always pull it off the Game Institute server if nothing's changed between now and the last time that the game was run. And of course the great thing about asset bundles is they allow us to update the game automatically from an end user perspective. So if we decide to add more levels, or we decide to add a new kitchen scene, let's say kitchen 4, a 4th kitchen upgrade, or we decide to add new ovens, new ingredients, whatever, as soon as the player loads the game, it will detect that the asset bundles have been updated. It will download that new content right into the game without the player having to do anything. But if nothing's changed, the asset bundles will be stored locally, so there won't be any downloading of assets. So let's load in the Bootstrapper scene and take a look at it. So here we are in the Bootstrapper scene, and of course it stands to reason that if you wish to run the game in its entirety from within the editor, then you really want to load the Bootstrapper scene in first before you hit that play button. Also, if I call up the game view, you can see there's actually no visual elements in this scene. In fact, you'll see that this scene really only remains the current scene for a split second. It executes just long enough for the application manager script to be instantiated and to start running. And then it immediately loads the next scene, which you'll see in a moment is the game installer scene, this scene here, that sits and waits for all of the asset bundles to download before it progresses onto the title screen. But we'll talk about that in a moment. But inside the Bootstrapper scene itself, we have the main camera. I mean, that's just the default camera, not being used for anything. Then we have the Scene Manager game object, which has this really simple script on it called Boot Scene Manager, which simply has a start function. And the first thing and only thing that this start function does is it loads the new game level, that game installer scene that we looked at just now. Like I said, when this game runs, pretty much all that happens is this scene immediately loads the next scene. However, what's really important is before that scene is loaded, remember this happens in the start function, it means our application manager will have already been instantiated, its awake function will have been called, and the application manager will be resident in memory. Let's open up the application manager and look at its awake function, because the awake function of the application manager is where the whole Matchmaker game begins. So if you want to follow through the source code, this is where you need to start your exploration. So here I am in the application manager, and obviously this video isn't going to be a source code walkthrough because there are thousands of lines of code, and that's what the official training will be for when it's released for this game. The only reason I've really opened this up is just to sort of scroll down to the awake function, which is the very start of the game. The awake function of the application manager. And you can see one of the first things it does is it sets this class variable called isAppReady to false. This is going to stay false within the application manager until the application manager has detected that all of the asset bundles have been downloaded and unpacked, and all of the assets that the game needs are now resident in memory for use. Of course, another very important line is the one that follows, which is Unity's don't destroy on load function, passing in this script's game object. What this is telling Unity is when the scene that this object was instantiated in is removed, is no longer the current scene, the object isn't destroyed along with all of the other objects. The application manager will always be resident in memory. And this is really important because you're going to see in a moment how when we go on to the next scene, which is that game installer scene, the application manager is still going to be running, it's still going to be downloading those asset bundles, which depending on the size of the asset bundle and the end user's connectivity speed could go from seconds to several minutes in length. And what that game installer scene is going to be doing is constantly asking the application manager how far through the loading process are we, and using that to graphically display a progress bar indicating 0 to 100% complete. Finally, this class also has a boolean called clear asset cache, which can be either set to true or false. It should definitely be set to false when you build your final project, but when you're working with asset bundles inside the editor, sometimes the caching mechanism can be a real pain in the ass, to put it mildly. For example, let's say that you're working on an asset bundle. You might not have added all of the assets that you want to that asset bundle yet, but as you add each one, you're testing the game just to check that it works and it's being fetched correctly. Now, the way that the caching system works with Unity's asset bundles is you give an asset bundle a version number, and before the asset bundle is downloaded, it will check the version number of the one on the server with the version number of the one that's currently in the cache. And if the one that is in the cache is the latest version, it won't bother downloading the asset bundle again. It will just use the one in the cache. However, when you're working with asset bundles, you don't always want to be incrementing the version of your asset just because you've decided to add a new sprite to it or something like that. However, what we can do using Unity's caching class, and in particular its clean cache function, is we can tell Unity at the start of the game when we press play to discard any of the asset bundles that may be cached and always fetch them clean and fresh from the asset bundle source, be that on your local hard drive or on a remote web server. So that's the awake function taken care of, and this is the first function that is called in the entire game. Of course, after Unity has called the awake function of every object, what it then does is calls the start function of every object. So when the start function of the application manager is called, notice that it has a return type of Enumerator, meaning that Unity will call the start function as a coroutine. And this is very important because this start function, one of the first things it does is it calls another coroutine called process application manifest. And this is the function that is going to download an XML file from our web server. It's going to check what asset bundles are available, as well as read in many settings that will be used to configure how the game plays. And that function may take several minutes to execute while it's downloading all of the asset bundles. Like I said, if you were downloading all the asset bundles, if you didn't have any in the cache, then we might expect this to take a minute or so for this coroutine to execute before the rest of the start function is executed. And the rest of the start function of the application manager just creates a brand new profile. It loads any saved profiles in from disk, and then finally, once everything has been done, it sets is app ready to true. Now, the thing to remember here is that we are executing this start function as a coroutine, and it calls as a coroutine the process application manifest function, which is once again a member function of the application manager class. We can imagine that this line here is going to be executing for several minutes. However, the very first time that boot scene manager start function is called, it's going to call the application class's load level function, which by the way is actually a deprecated function now, but I'll leave it in there for now. And it's going to load the game installer scene. Now, just to remind you once again, the game installer scene is this scene here. Okay, when this scene is loaded, the application manager that was instantiated in the previous scene is still in the middle of its start function, and that start function may take several minutes to execute. All the while, this scene is going to be updating this graphic based on the download process of the application manager. Now, this scene may be waiting for a minute or so while it's updating its graphic before it finally asks the application manager, is the app ready to proceed? And we saw just now in the start function of our application manager that the last thing it does at the very bottom of the start function is it says is app ready equals true. When we set this to true, the game installer scene will finally be told the app is ready, and then this scene will then load in the title screen and the game will begin properly. And at this point, all of the assets from the asset bundles will have been unpacked, they will be resident in memory, and all of the other scenes in the game from this point on can just treat those assets as if they are regular assets that were included in the build of the executable. So if we go back to the bootstrapper, just to show you what I mean, if I press play now, because I have asset bundles in my cache, you'll see that the game installer scene is going to update very quickly and go straight into the title screen. So I press play, the bootstrapper scene immediately loads the game installer scene, which, because the asset bundles are cached, almost immediately loads in the title screen. However, if I go back to our application manager and I tick that little boolean called clear asset cache, which remember was what we tested in the application manager's awake function, and if it was set to true, we use the caching class's clean cache function to get rid of all the asset bundles. If I press play now, you'll see that we now have a very lengthy process in the game installer scene while those asset bundles are being fetched from the server. Now, while we're in this scene, the start function of the application manager is continually running as a coroutine, updating all of the asset bundles, and only when the start function has downloaded all the asset bundles, fetched all of the profile data from disk, will it return that the app is ready to this scene, and then this scene will load in the title screen. And like I said, at this point, all of the assets from the asset bundles have been unpacked, resident in memory, and the other scenes in the application really just see those assets as if they're just regular assets that were baked as part of the build. So what we need to do is just talk a little bit about using asset bundles in a project. If you don't know what asset bundles are, if you don't know what I'm talking about, then you need to go to the Unity documentation right now and read its entire section on asset bundles, okay? Because I'm not going to describe to you what they are or how they work. All I'm going to say is how we use them in development so that we're not always forced to fetch asset bundles from the server each time. Because some of you, if you're just developing, might not even have a web server that you can put the asset bundles on. So we're going to look at how we can, in the development process, store and fetch the asset bundles from a local folder on your hard drive. Asset bundles are a really cool feature in Unity because they allow us to build our application in a distributed way and in a way that gives us an opportunity to have the assets that's used by the game exist in packages that are distinct from the compiled executable. Now, what's really cool about this is I'm sure you've all played games, and I can think of one example was Fallout 3. I remember playing Fallout 3, and after I'd completed the game, it wasn't long before they started releasing some downloadable content, DLC packages. These are very similar to asset bundles. I could simply purchase a DLC, it would download, and it would add a whole load of new functionality to the game. And that's really like how the asset bundles are used in Matchmaker. Asset bundles can contain resources such as textures, models, sprites, prefabs, sound files, or in the case of Matchmaker, even complete scenes. In fact, most of the gameplay in Matchmaker takes place within the kitchen scenes. We have 3 kitchen scenes here, and this scene that you're seeing here of Kitchen 1, it exists entirely in an asset bundle along with all of the other kitchens. So these scenes will not be built as part of the main executable, but instead will be fetched when the executable is run and will be unpacked into memory so that it's then reachable and accessible by the game. And of course, the great thing about this is if I decided to add 5 more kitchens to this kitchen bundle, then I could just update the asset bundle on the web server, deploy that with a new version number, and the next time that any end user that has already installed our application runs the Matchmaker game, it will automatically detect that a new asset bundle is available, and automatically the player will see all of this new exciting content waiting for them. So essentially you can use it as a kind of patching system. Now there are some limitations to asset bundles. You don't generally store scripts in asset bundles because they would just be stored in there as uncompiled C# scripts. So really asset bundles are just for storing assets, and all of the main code has to be built into the executable. So working with asset bundles in the Unity editor is kind of a 3-step process. The first thing we have to do is identify which assets we wish to exist in asset bundles and mark up those assets so that the editor knows which bundles they're supposed to be in. Now we're going to come back to that in a moment and look at it in a bit more detail, but just know for now that when you select any asset, be it a scene, a sprite, a prefab, and look at it in the inspector, you can see that at the very bottom of the inspector window, let me choose the practice scene here, you can see that it has this little asset bundle drop down, and we can see that the practice scene, which is one of the scenes that is compiled into the main executable, has got none for its asset bundle, in which case this will not be a scene that is compiled into asset bundles but will be built into the main application exe. However, if I choose one of my kitchen scenes, you can see that this has been assigned kitchens/kitchen1. That means once we've decided where we wish to build our asset bundles, this bundle is going to be in a bundle called kitchens1, and that's going to exist in a subfolder called kitchens. And you'll see that kitchen1 scene, kitchen2 scene, and the kitchen3 scene all exist in the kitchen subfolder and in the kitchen1 bundle. And using this little asset bundle pop-up in the Unity editor, we can create any number of subfolders and any bundle names we want. So you can see here that the game actually builds 3 separate bundles when I build the asset bundles. The first bundle is called Common Bundle, and this exists in the root being wherever we decide to build our asset bundles to, and we'll talk a little bit about the asset bundle build location in a moment. But if we imagine that our bundles are on the web server, then this is kind of the bundle that's going to exist in the root of that server location. And then underneath that, I've created another bundle called Game Pieces 1 that I'm telling Unity it has to exist in a subfolder called Game Pieces on the web server. So whereas Common Bundle would exist in the root directory, there would be a Game Pieces subdirectory with a Game Pieces 1 bundle in it, and a Kitchen subdirectory with 2 bundles in it, one called Kitchens 1 and another bundle called Kitchens 1 Store Images. So actually it's 4 bundles, isn't it? So that's how we mark up all the assets and tell Unity which bundles we want them to be in. And of course, this takes quite a bit of planning because the asset bundle system is pretty clever. So let's say, for example, that I created 3 separate kitchen bundles, and each one of those kitchen bundles had kitchens in it which used the same oven prefab. Now Unity is intelligent enough to know, well, I don't want to create a separate copy of that oven in each of the kitchen scenes, or otherwise it's going to exist in 3 bundles, and when I've got all 3 bundles loaded, I'm going to have 3 copies of the oven resource in memory. So what it will do is it will only store an asset in one of the bundles in the bundle chain, and then the other bundles will then have dependencies on that bundle. So in order to make that more clear, let's say that when I chose to build the asset bundles, the oven sprite and prefab was put in the kitchen 1 bundle. Well, then kitchen 2 and kitchen 3 wouldn't have that oven resource in it, and they would have dependencies on the kitchen 1 bundle. And this can be a little bit of a pain to resolve at runtime. Now, this isn't really a problem with Matchbaker, because in Matchbaker all of the bundles that are available are always loaded all at the same time. So if there were any dependencies, they would automatically all have access to one another. But in Balls of Glory, for example, that wasn't the case. I had 3 separate themes: the Haunted Ruins theme, the Dark City theme, and the Candyland theme, and they all had dependencies on certain sprites and graphics that I didn't want to have duplicated across all 3 scenes. But at the same time, the user could choose to only install certain asset bundles. So if we chose to install, for example, just the Candyland bundle, and that Candyland bundle had a dependency on the Dark City bundle, well, then we would have missing assets or undefined asset references. So the way that I like to get around this is any assets that I think are going to be used by all of my bundles, I store in a bundle called the common bundle, which is going to be the first bundle that is loaded. So that the common bundle gets loaded first. Anything that's going to be used or referenced by the other bundles are not going to have a problem, because the common bundle is always going to be loaded. So I stop having this situation where I might have 3 or 4 different kitchen bundles all dependent on one another. So if I just drill down into my prefabs folder, you can see that I have a folder here called Baked Products, and this contains all of the prefabs for the cakes that we can bake: banana cream pie, blueberry muffin. You can see that all of these pieces have been assigned the Game Pieces 1 bundle inside the Game Pieces folder. If I go down into the UI folder, you can see that I have some graphics here, such as the header bar, which is in the common bundle, because I know that this is going to be getting used by all of my kitchen scenes. And that's also true for the oven highlight. The oven highlight is what basically highlights the oven when it's selected. Once again, I don't want this duplicated across all of my kitchen scenes, and I certainly don't want my kitchen scenes having interdependencies, so that's why I store these in the common bundle. Once again, if I go into my ingredients folder, you can see all of the prefabs that have been set up with all of their scripts and properties, and these are the ingredients that we're going to mix on the matchboard to bake our cakes. And once again, all of these prefabs have been assigned to the Game Pieces 1 bundle. That's the same bundle that contains all of our baked products, and same too as the ovens. The ovens also exist in the Game Pieces bundle. So if I select my ovens subfolder inside my prefabs folder, you can see that there we have an oven called the Cake Bake Pro. Once again, it has all of its scripts, all of its functionality, and that prefab is simply assigned the Game Pieces 1 bundle. And so too is true with all of the other ovens. The only exception in this folder is the oven mount, which is actually part of the kitchen scenes. Every kitchen scene has oven mounts, which is where we mount the ovens onto, and as you can see, I've assigned this to the common bundle as well, because it has to be used by all of the kitchens. So you can see sometimes it takes a little bit of figuring out to know which assets need to exist in which asset bundles, but if you design it with a clear and clean design at the start, you shouldn't have too many problems. Okay, so we've seen how we can tell Unity which assets should belong in which asset bundles, but what we haven't seen is how we build those asset bundles. And strangely enough, up until this current version of Unity, I'm currently using Unity 5.6.0, there is no button or menu option in the editor's UI to automate the building of asset bundles. We actually have to write a script that uses the build pipeline class and then use that class's API to trigger a build of the asset bundles. Now, fortunately, writing a script to build the asset bundles is very, very simple, and you can find my asset bundle building script in my scripts folder and in my editor folder. And it's very important that the script that we write that uses the build pipeline API to build asset bundles does exist in the editor folder. So if there is, it's called create bundle, and if I load that in, you can see that it's simply a static function with a void return type, takes no parameters, and I've called it build all asset bundles. I've just put this in a class called asset builder. And furthermore, what I've done is I've used the menu item attribute, which is going to tell Unity that it wants to add an item to the assets menu, and it wants this to be called build asset bundles. And you can see if I go back to the editor now, there is indeed an option to build asset bundles, and that's our little editor script there that is adding this to this menu. And furthermore, when we select that build asset bundles option from the menu, what's going to be executed is this function that is underneath that attribute. And you can see that this is a really simple function. We use the build pipeline class, and we use the build asset bundles function of that class. And as the first parameter, we send in where we would like the bundles to be built. I want them to be built in our assets folder and in a subfolder called asset bundles. And if I go back to my project and look in my assets folder, you can see I have indeed created a folder in there called asset bundles. And in fact, if you look in the asset bundles folder, you can see that because I've already built the asset bundles before I started recording this video, the bundles actually exist. There's our common bundle there. And we also, you can see the game pieces subfolder and the kitchen subfolder have been created, and in there too are the bundles. If I go back to the build asset bundles function call again in our editor script, the second parameter allows us to determine how the bundles are built. And I'm actually using an option here that says deterministic asset bundle, which basically means that it's going to kind of drill down and fetch in any dependencies. So if, for example, we include, let's say, a prefab of a sprite, well, that sprite might have many other things attached to it. It might have sound sources, to name materials, that sort of thing. Using this option means that it will find all of the things that the asset uses and include that in the bundle as well. And that's really cool, and it's probably what you're most likely going to want to use. And a classic example where this is really useful is when we add entire scenes to an asset bundle, which is the case with our kitchens bundle. Just to remind you, if I go into our scenes folder again, you can see that we have kitchen 1, which is a scene that's been assigned the kitchens bundle. But of course, if we load in kitchens 1, we can see there are loads of things in that scene. There's sound effects, there's sprites, there's the positions of all those sprites, and various kind of hookups and references being made between all those objects. And when we add this to an asset bundle, because our building function is using the deterministic asset bundle as its second parameter, it means that when that scene is put in the asset bundle, not just the scene file is going to be put in the bundle, but also every single asset that it uses. Unless, of course, some of those assets have already been built in asset bundles further up the hierarchy chain, such as in our common bundle, in which case they won't be included again. Finally, as the third parameter, we just specify one of the build target enumeration. Here you can see I'm building asset bundles for standalone windows. So if you're building your asset bundles for, let's say, WebGL, if you're building them for iOS, then you need to use a different version of this enumeration that suits your build platform. But I'm building for standalone windows, which is what my version of Matchmaker is for. So I'm going to go to that asset bundles folder, and what I'm going to do for now is I'm going to delete all of the asset bundles. Okay, now notice that I've deleted everything in that folder except a little XML file here called the XML manifest. Now that isn't part of the asset bundle system. That is an XML file that I've created, which is going to describe to the application where all the asset bundles are, which version the asset bundles are, and as well as contain a whole host of configuration information for how the game plays. So we don't want to delete that, okay? Okay, so I've now got rid of all the asset bundles. But because I've marked up all of the assets that I want to be in the asset bundles in the editor, and I now have this build asset bundles menu item, if I choose that and wait, you'll see that Unity will now build all of my asset bundles for me. There you go, and the bundles have all been built. And if we look in our asset bundles folder again, we can see once again that the common bundle has been generated again, and so too of our game piece bundles and our kitchen bundles. Now you'll notice that when asset bundles are built, this essentially, it looks like there's two files with the same name. For example, we created a bundle called common bundle, and this is actually the binary bundle here, but there's also another file that's been created with the same name. But if you look in the bottom of the project view, you can see this is actually called commonbundle.manifest, and Unity will build a manifest text file for every asset bundle. And that just isn't something that we need to use. You can use it, but Matchmaker doesn't use it. But it just contains all of the assets that are in that bundle, all of their IDs, and also describes any dependencies. So you can see if I just select this common bundle manifest, it lists all of the resources that I added to the common bundle, And at the bottom it shows a list of dependencies, and you can see that my common bundle has no dependencies, and that's good because it's the first bundle that's going to be loaded. It's this bundle that other things are allowed to have dependencies on, but we don't want the common bundle having dependencies. And we also said that, for example, the header bar prefab here, which you can see I'm moving my mouse over, which was in our prefab/UI folder, is used by all of our kitchen scenes. That's basically this thing that you see here, and we don't want it included 3 times in each kitchen bundle, so we've included it in the common bundle. And now if I drill down into the kitchen subfolder and choose the kitchens 1 bundle, sorry, not the bundle, but it's text manifest, you can see now that there are 3 assets in this bundle, 3 scenes, kitchen 1, kitchen 2 and kitchen 3. But it also shows us that this asset bundle does have a dependency on the common bundle because of that header bar. And actually there's a few other shared assets, so we need to make sure that in order for these scenes to run, the common bundle needs to be loaded and accessible, and preferably loaded first. Finally, if we go back to the root asset bundles folder, you'll also notice that as well as being a text file next to all of our asset bundles, there's also a text file just called asset bundles, and that just gives us a nice rundown of which bundles have been created and which dependencies there are. So you can see if I look at this text file, it tells me that the first bundle is called common bundle, it has no dependencies. The second bundle built was called kitchens 1, and that has a dependency of the common bundle. The third bundle was called the kitchen 1 store images bundle, that had no dependencies, that was really just a collection of sprites to use in the store. And there's also a game pieces bundle which also has no dependencies. So it's only really the kitchens that have dependencies on the common bundle. One of the things you have to remember when using asset bundles, and this is a real gotcha, you'll forget to do this a lot because I do, is if you change any of the assets and press play, you're not going to see anything change because you haven't rebuilt the asset bundle. So look at this kitchen, for example. This is the kitchen 1 scene, which we know we built into the kitchen 1 bundle. So let's say I decide I want the door to be down here when I press play. Now if I press play now, I haven't rebuilt the asset bundle with this new scene. So although the scene exists in our project with the door in its new position, of course once we press play, the scene is actually going to be getting fetched from the asset bundles, which contains the outdated version of the scene. So to show you what I mean, I'll go into the game, I'll go into the first level, I'll install an oven, and then when I press play, look, you can see the door is in its old position, it's not in its new position. So that's something you have to remember to do. If you change any of the assets, you need to click that build asset bundles again. So we now understand a couple of things, right? We've seen how I've assigned my various assets to those asset bundles, and we've seen that asset bundles are really used for content that we may wish to change or update without requiring the end user reinstall the executable. So in the cases of my 3 kitchen scenes, they exist in a kitchens 1 bundle. Now the reason I call this kitchens 1 and not just the kitchens bundle is that our application manager can handle downloading and installing multiple asset bundles of a given type. So just to be clear, let's say I created 3 additional kitchen scenes that all had different graphics and different capabilities, and I wanted those to be added to the game whenever an end user next runs our executable. One way that I could do this is I could rebuild our kitchens 1 bundle here, but next time when I rebuild it, add 3 more scenes to it. Or another way that I could do it is those 3 new scenes that I've added to my project, I could build into a second kitchen bundle, let's say, that was called kitchens 2. And our application manager will handle that file and it will download multiple bundles of a given type. And of course we also have our game pieces bundle, which contains all of the assets that we wish to really maintain outside of the main executable. Things that you can buy in the store, things like ingredients, baked products, ovens that we can upgrade, just all the various components of the game that we may wish to change or add to. And once again, if we decided to create another asset bundle called game pieces 2 and store a load of new ingredients, a load of new ovens and a load of new baked products in that, then that would work fine. We could have multiple game piece bundles allowing us to add to the game incrementally over time. And we also learned how to choose where we want the bundles to be built, and currently I've got them being built in this asset bundles folder. And of course when you build your final executable, you're definitely going to want the contents of this asset bundles folder to be uploaded onto a web server so that the asset bundles are actually fetched but from your web server and can be changed and maintained by you. They're no good at all to you if the asset bundles end up being on the end user's hard drive. But what we haven't seen at the moment is how we tell our project in the editor to use these bundles that we've just built on our hard drive, because if you've just downloaded the project from the Game Institute website, then currently the project will be downloading the bundles from the Game Institute web server. So it doesn't matter how many times you change and rebuild the bundles in your project, nothing is going to change because those aren't the bundles your game are using. So in order to change where the bundles are taken from and change them to this local directory on our hard drive, we have to once again load back in the Bootstrapper scene and revisit the application manager. And if you look in the inspector, you can see that right at the top there we have this property called manifest URL. And now this is the URL where we wish our project to fetch the manifest from, which is an XML file which also exists in the root location of our asset bundles. You can see there is our application manifest there, and we'll talk a little bit about the application manifest in a moment. But from the application manager's perspective, the manifest URL is not only the location of the application manifest XML file, it's also assumed to be the root folder of the asset bundles. So at the moment, it's fetching the bundles from www.gameinstitute.com/matchmaker/desktop. Okay, what we need to do is change that to this folder on our hard drive. Now, I'm using Windows 10, so my actual project here that you're looking at is actually this folder on my desktop. Okay, so if I drill down into Matchmaker, and then I drill down into my assets folder, and then I drill down into my asset bundles folder and do properties, I'm going to then copy that to the clipboard. So I'm just going to paste that in there. And furthermore, because we are fetching this from a file, not HTTP, what we need to do is at the beginning of this URL, we need to do file : and then on Windows 3 forward slashes. I think on Mac it's only 2. I think that's a bit of a weird Windows idiosyncrasy there, but I don't ever do anything on a Mac, so you know, you'll have to look in the Unity documentation for this, because this is really just using Unity's www class to fetch the application manifest. Okay, so if you look at the www class in the Unity documentation, you'll see how this manifest URL should be formatted on your given platform. But I believe I've got that right for Windows. So if I press play now, we shouldn't get an error. Yes, this is loaded now, the asset bundles from my local hard drive. So let's put that to the test. Okay, I'm going to go to scene 1 in my scenes folder, and I'm going to do what I did before, which is I'm going to drag that sprite of that door down, say something like that. Then I'm going to save that off, and I'm going to rebuild the asset bundles. Okay, remember, this is rebuilding now the asset bundles into my local asset bundles folder. And of course, as we've just discussed, we've now told our project to use these bundles from this location. So when I press play, we should see that door in its new location, and then we know that our project is correctly using the bundles on our local hard drive. Now, as you can see, the door has not moved. So what on earth could be going on? Well, we talked about this a little earlier on, one of those got yous. So let's go back to the application manager for a moment in our Bootstrapper scene, and let's tick clear asset cache, because I would imagine what is happening here is that although we've rebuilt the bundle in our project, our actual game is saying, hey, nothing's changed, the version number of the asset bundle is still the same, so I don't need to refetch that asset bundle from that location. So what's happening is it's just using the outdated asset bundle in the cache. Now I've cleared the cache, I think we're going to see that door in its new location. Hey, there it is. So a couple of got yous there, right? First of all, when you make any changes to your assets, make sure you rebuild the asset bundles. And if you're working within the editor, probably want to have that clear asset cache ticked at all times and only untick it when you're ready to deploy. Or either that, or you need to open up the application manifest, which we'll talk about in a moment, and assign your rebuilt asset bundles a new version number. You don't want to be updating the version of your asset bundles every time you just make a tweak to it in development. So the best thing to do is clear this asset cache. This is a really cool little tick box, which is going to save you a lot of problems. So what I'm going to do is I'm going to go back to my kitchen 1 scene, and I'm going to move the door back up right there. I think it was about there. Save that off. Now if I rebuild the asset bundles, I won't have to worry about doing anything else, because the next time I press play from the Bootstrapper scene, I'm clearing the cache. So I'm going to go back to the Bootstrapper scene, press play, and we should see the door back in its original location because it's automatically using the new updated version of the bundle that I just built. Okay, cool stuff. Okay, so if you didn't before, hopefully now you have a better understanding of what asset bundles are, how we assign assets to them, and how we build asset bundles. Furthermore, we've also seen how we can choose where the asset bundles get built on our local hard drive, and perhaps more importantly, how to configure our project so it uses these locally stored asset bundles instead of the bundles on the Game Institute web server. Those bundles in a way are useless to you if you want to play around and change the project, because you have no control over updating and redeploying those bundles on the Game Institute server. So having the application configured so that it's using your asset bundles on your local storage is of course a vital step so that you can play around and change the project as you see fit. Okay, so as this video has drifted on a lot longer than I thought it would, I'm going to end this video here, and in the next video I'm going to talk about the application manifest. Now the application manifest, remember, is this XML file that is in our asset bundles folder. There it is, application manifest.xml. And pretty much loading in this XML file is the first thing that the application manager does, because the XML manifest controls pretty much every playable characteristic of the game. It defines all of the ingredients that are needed to be mixed to bake a cake. It contains all of the characteristics of an oven or a kitchen upgrade. And it contains a descriptor for all of the levels, meaning how much time you get on that level, how many cakes you have to bake on that level, and so on. Furthermore, the application manifest is also responsible for the versioning system of our asset bundles, so that's pretty much the missing piece that we haven't discussed yet in our asset bundle coverage. If I open up this XML file, you can see there are several definitions of bundles in here that have a version attribute, and that's how we tell Unity what the version of the bundle currently on our web server or in our asset bundle folder currently is. Unity will check this version against the version of the asset bundle that it currently has installed in the cache, and if this version is higher, then it will re-download and install the asset bundle. Therefore, if we update an asset bundle and we redeploy that bundle such that we wish all of our end users to have that installed on their system, all we have to do is just come into this XML file and update the version, say from 1 to 2. In this case, I've configured the version of the common bundle, and the next time any of the users run our game, they're going to download this XML file and they're going to see that the version of the common bundle is 2, and that's got a higher version than the common bundle of 1 that they might have in their asset cache, and what it would do is force a re-download of this bundle. So that's pretty much how the versioning system works, but we'll talk about this in more detail later on. And really the next video is just going to be pointing you in the right direction so that you can see where to start to examine the code that processes this manifest file and loads in the asset bundles and makes all of that content available to the other scenes in the game. Thanks for listening, and I'll see you in the next video.